chapter 6, we're going to talk about databases. We're going to talk about the use of databases within organizations, and we're going to get into business intelligence, which is one of the kind of outputs of utilizing a database. Okay, so a database is you can think of a database as a group of related, they call them files, but I would say they're more like tables, okay? A file is a group of records, a record is a group of fields, and a field is a characteristic of something called an entity. So in a database, you're looking at trying to save information about a person, a place, a thing, a transaction, right? So there's a database here on campus that has information about you guys as students, about me as a faculty member here or an employee, okay? And we would all be considered entities in that database, okay? And an entity is just some characteristics. So when you think about you as a student, what are some of the pieces of information that the University of Laverne keeps about you or wants to keep about you as a student?
Like what our major is.
Right, your major.
Maybe like how we do things about tuition, maybe.
Maybe, but you can even get down into the the very basic stuff, right? Address, right? City, state, your whole mailing address, phone numbers to get a hold of you, emergency contacts, first and last name. How do they uniquely identify you?
Student ID.
Your student ID, right? And in a database, that is called a primary key, okay? So when you walk into any of the offices here, right, they don't ask you for your first name, right? Why don't they ask you for your first name?
Because there's a million people with the same name.
Right. What about last name?
Multiple last names.
Yeah, right? Even the combination of first and last name, right? So they create these artificial identifiers that when I walk in, I have an employee number, and when I walk in and I'm going into HR personnel, they ask me for the employee number because they don't want my first, my last name. Lytle-Kosola is probably not very common, but they still don't want to search for that because when they put in that employee number or your student number, they're going to get right to the information for you as a student or me as an employee. Okay, that's actually one of the powers, one of the very useful parts of a database is that you can store information and keep track of it using these primary keys, these unique identifiers. Okay, so when we're looking at a database, right, they talked about different files. Your book calls these files, I would call them tables. Okay, in a database you have tables in the My Laverne 2.0 database where you have all your information, right? There's a student table out there. There is an employee table or file that has information about each one of us. Okay, and in that file or that table, right? When you get into a database, it sort of looks like an Excel spreadsheet where it's got records of information, right? And each record, right, each one of you is a record in that student table. Okay, you're one complete set of information for you as a student. Okay, where they keep all, that first and last name, your full mailing address, your phone number, maybe your major, other important information that they keep about you. Okay, so and each one of those pieces of information would be considered a field. Okay, and a record, you as an individual, is a collection of those fields together. Okay, you're one part of that database. Okay. Now, traditional ways of storing information, not using databases, right? You run into some issues. Okay, you run into things like data redundancy, having multiple copies of the same data in different places. Okay? If you've ever changed your address, you move somewhere and you call and let a business know that you're changing your address, right? But for some reason you're still getting mail at your old address as well as your new address, right? If you've ever had that happen to you, that happens because they have your information in two different places in their system, and when you called and updated that information, they updated it in one part but not the other. Okay? So when you have data redundancy, those are some of the types of issues you might run into. Okay? Inconsistency, if you have redundancy, right, you have the same data in multiple places, the chances of that data being inconsistent, where you have the same values with the same information with different values, right? So for Nicole Lytle-Kosola, having two different addresses in the same system, that's data inconsistency. And again, when you have multiple copies, you increase the chance of having that. Okay? You also have issues with they call it program data dependence, but having whenever you make changes to a particular application, right? Updating a web page. Okay, you update a web page. If the data is dependent on that program, when you make changes to the program, you have to make changes to the database too, and that could be a nightmare. Once you create a database and you start putting data in it, it's really hard to make changes to it after there's already data in it and you're using it. Okay. So you don't want to do that. You want to have a level of independence between the applications that are using the data and the database itself. Okay? You end up with a lack of flexibility when you're not using a database, possibly poor security, okay, and a lack of data sharing and availability. So if you're using a traditional filing system, you know, I'm a Kaiser member, and Kaiser recently in the last 5 to 7 years started to move away from paper patient files to electronic files. Okay? These paper files, if I was being seen in one department and the file stayed in that one place, only that doctor or the people who were actually seeing that paper file could benefit from it, could actually see what was in it, could use it. Okay? With these electronic files, anybody that goes into the system, looks at my name, looks at my information, can see it because they're all looking at one electronic copy and sharing that information. Okay, it's the same idea. Okay, so this is where we're looking at traditional file processing, where you have different parts of the organization that are not able to share information, different applications for different parts of the organization, where they have information that could be duplicative information that that has some of those issues like data redundancy and data inconsistency. Now, a database itself is a storage container for data. In order for a database to be useful, it needs a piece called a database management system, or DBMS. Okay? The database management system actually is the piece of software that does all of the work. When you're creating new records, when you are updating records, when you're accessing records, you're accessing the database through the DBMS. Okay? It also keeps separate logical and physical views of the data. Now, what's the difference between a logical and physical view? A logical view is how users actually see the data, which is different than the way that it's actually physically stored. Okay? The physical view, the only people that see the physical view are data administrators, IT professionals, people that actually get into the database itself. And the cool thing about the database is that we don't, as end users, we don't care how it's physically stored. Okay? As long as we can access that information using a primary key, I don't care where Nicole Lytle employee information is stored in the MyLaverne system, as long as I can go into the system, put that primary key, that employee number in there, and pull up that information. I don't care where it's coming from. So as a user, I don't care about the physical view. Think about an Excel spreadsheet, right? When you're looking up information on an Excel spreadsheet, what do you actually have to know to find information?
Information in the tool, right?
Yeah, well, you have to know the physical location, right? The column and row information, right? You have to know that that piece of information is at A10 and is in that particular cell. That's the physical location, right? With a database, we don't care that that piece of information is at A10 or double W25. It doesn't matter as long as we can access it using that unique identifier. Okay. And of course, databases help with some of these issues, so helping with redundancy, inconsistency, creating that separation between your application programs and the data, and helping you to manage the data centrally, as well as improving security of the data, right? Because it's all in one place. We only, instead of having to manage security in multiple places, we just have to be aware of the security in that one central place. Okay. So here, this looks at this database approach and looks at the human resource database, your DBMS, which again is the piece of software that does all the heavy lifting and all of the work, right? And shows that in different applications, you're going to get different logical views of the data. But again, you don't have to concern yourself as an end user with the physical view, just what you're actually able to see, right? Payroll can see different things versus what people that are concerned with benefits can see. Okay. Now, a relational database, or DBMS, represents your data as two-dimensional files, okay? And each one of these tables has data on entities and attributes, all right? And a table is a grid of columns and rows, sort of like a table sort of looks like an Excel spreadsheet. It acts differently, okay? It has those rows, which each row is a record, has fields, which are those columns, the attributes. And again, we talked a little bit about a primary key. A foreign key is a connection from one table to another using a primary key structure. So we can take a look at how this is done. This is a table for a supplier information. Okay. Here, the supplier number is the primary key to uniquely identify information for a particular supplier. Okay. These are columns here, and these here each are the rows or the records. Okay. Now here, we have that supplier information with that primary key, which is the supplier number. Okay. If we have a part in our database, right, a part table, each part comes from a particular supplier. Okay. So to identify which supplier a part comes from, all we have to do is connect the part table, that particular record in the part table, with the primary key from the supplier. And that's going to connect it actually to all of this information here, all of this supplier information here. Okay? This is called, now when you're using a primary key in another table, it's called a foreign key. But this primary key, foreign key structure is how these tables connect to one another. And again, that's where you get the relational database model, because it's relationships between tables. Okay? Now, I'm not going to test you on this, so I'm not going to talk about it, but the different operations of, a select, join, and project, this is something that you would get into if you had a database class. So I'm not going to talk about it, and I'm not going to test you on it, so don't worry about that. Object-oriented databases look at entities as objects. And when you're looking at an object, An object has attributes and characteristics, but an object can also do things. Okay? So instead of looking at data and the things that the data can do separately, it brings those two things together in this idea of an object. Okay? They're a little bit slower than relational databases, so they're not used as extensively. And you can have some hybrids between those two, but again, the relational database model is by far the most used model in databases. You can also have databases in the cloud, but again, these types of databases are going to have less functionality than databases, full-fledged databases that you have in your organization. Okay, some of the capabilities of database management systems include things like the ability to define your data definition capability, the ability to define the structure of the database. It's sort of like looking at building a container before you put any water or any type of fluid or anything in it, right? You need to have the structure, and that's going to set up the way that the amount of and the type of information or the type of stuff that's going to be able to fill that container. Okay? The data dictionary actually talks about the data itself. So when you're looking at data, something like a first or last name, for a first name or a last name, right, how many characters is that first or last name field, right? Is it 12 characters? Is it 15? Is it 20, 30 characters? Last names seem to be getting longer and longer, so these are the things that database designers have to think about when they're building these databases. Okay? What type of input can it accept? Okay? You have certain fields that will only take letters. Others will only take numbers. Some of them will take free text, any type of text. Okay, so these are the types of things that go into the data dictionary. Okay, and then you have data manipulation languages. SQL is the standard data manipulation language when you're creating databases, when you're creating fields, when you're inputting information, asking questions of the data. Basically, they're called queries. You're doing that all in structured query language or SQL. Okay. Microsoft Access has its own tool called Query by Example, or QBE. Okay, it's a little bit. Microsoft Access is a special case of a database. It has SQL, and you can use SQL in it, but you don't have to use SQL. You don't have to write a single line of code in order to use and build databases in Access. Okay, and a lot of databases have reporting capabilities in them. Okay, so this is an example of an Access database. This shows the design view of a supplier table, and you'll notice here it has the name of the field, and it tells you what type of data it will accept. Okay, auto number means that when you put in new data, it starts from 1 and it keeps counting down, automatically. Okay, text means it'll accept any type of text, special characters, anything like that. Okay, and when you can see here, there's a little key designation. That's the primary key designation. You click on the field name, and you'll see down here there are field properties for that particular supplier name. It has a field size of 50. It can take up to 50 characters. Okay. This is an example of a SQL query. Again, this is not something I'm going to, you're not going to have to write SQL queries, so don't worry about it. This is the type of thing that you would get into if you were to take a database class. Okay, this is looking at an Access query. Okay, and again, remember I told you that Access has its own interface called Query by Example, or QBE. This is the QBE interface. You create a query, right? This one's going to include part number, part name, supplier number, and supplier name. It's including information from 2 different tables, right? And the criteria here is it's going to show any data where the part number is 137 or 150, okay? And you could actually write SQL code that will do the exact same thing. Now, when you're designing databases, again, you have two different views of the database. The logical design, which again, this is how end users see the database. This is how, this is the database information from the business view. The physical design, this is how it's actually stored in the database. Okay. So the design process is where you are identifying the different entities, the different type things that you want to keep track of, you want to keep information about, and how those things are related. Okay? Normalization is actually taking, streamlining groups of data in a way that make it efficient, figuring out what pieces should be in tables together and what should not be in tables together. And again, normalization, you know, there's all kinds of stuff that goes into this idea of normalization, but again, that's something that you would learn if you took a database class. Just know that this is a process to start in the database design process. Okay? And this is sort of an example, right? You can see that this is actually an order information before data before it's normalized. Okay? How many different things do you see in here? Entities. How many different maybe groups of things do you see in here? There's at least 3. Yeah, there's 3 are easily identifiable, right? You have stuff that goes for the order itself, right? The part, okay, that you would be ordering, right? And the supplier, right? You can, if it's unnormalized, you're throwing all those things together. When you normalize it, you're starting to pull all of those things out into their own tables. And you're going to connect, they're still going to be connected, but they're going to be connected using that primary key, foreign key structure. Okay? Now in database design, the modeling technique is called entity relationship diagramming, or ER diagramming. It's used to document the data model, and again, before you write a single line of code, before you sit in front of a computer to create a database, you have to create this model to figure out what tables are we going to have? How are they going to be related to each other? What types of information do we need to keep in each table? Okay. You can also have distributed databases, and there's 2 different types, 2 different ways of distributing databases. One of these ways is where it's partitioned. You have separate locations where you're storing different parts of the same database, or replicated, where you have a central database and it is duplicated in its entirety in different places. Now, replication is something that a lot of companies use. Why do you think replication is a good idea and something that a lot of companies use? Backups, right? For most companies, their data is their most valuable, intangible asset, and you want to make sure that if something happens to one copy, that you have a backup to function from. Okay, so this is an example of an entity relationship diagram. There's multiple diagramming techniques. This one here is called the crow's foot. If you'll notice here that this piece right here, it kind of looks like a crow's foot. So, but you can look at, supplier, a part is supplied by a supplier, right? A supplier provides a part. Each supplier provides one or many parts. This is This is how you read it. But you would set up your diagram so that you can see the relationships between different tables and different pieces of the database. Okay? Now, very large data sets require special tools. Okay? You want to be able to analyze large sets of data, and you also want to be able to access that data from multiple systems. Okay, so there's 3 main techniques we'll talk about: data warehousing, data mining, and other types of tools for accessing databases through the web. A data warehouse is a collection of multiple data sources, internal as well as external. Data warehouses are expensive to set up and maintain, but the insights that they create for companies can usually see you'll usually see your investment back, you know, over and over again. Okay. Data warehouses have historical data. Once the data is in the data warehouse, it doesn't change. Okay, so it's going to be separate from your operational databases. Data marts are subsets of data warehouses. So a company can usually only afford to have one data warehouse, but they might need the ability to access parts of that data warehouse in different parts of the company. So you would create data marts that a lot of times will support the operations of a particular department or a particular part of the organization. Okay. Now this is looking at the components of a data warehouse, and again, you usually have internal data sources as well as external data sources. It goes through all of these different data sources go through a process called it's actually the ETL, extraction, transformation, and load process, where you're basically cleaning all of the data up, getting it into the best shape possible, because once it gets into the data warehouse, it's never going to change again. Okay? Goes into the data warehouse where you have the ability to utilize and access that data and do some higher level business intelligence functions. Okay? So business intelligence is a whole collection of different tools for analyzing, consolidating, and providing access to these vast amounts of data that are available in your data warehouse. Okay? It gives, you know, they give you an example here of Harrah's, which is the parent company of not just Harrah's, but a few other casinos in Vegas, being able to analyze their customers to figure out who are our most valuable customers, who are the people that spend and probably lose and gamble a lot of money, right? The people that we give perks to, like free, you know, free buffets, free dinners, free nights. We want them to come back and lose more money, right? So we identify them so that we can offer them these special promotions, okay? Without data warehousing and without these business intelligence tools, they wouldn't be able to do things like that, okay? So we'll look at some of these different tools, okay? Online analytical processing, or OLAP. This supports something called multidimensional data analysis. This is where you're looking at data using different dimensions, okay? You're looking at data, and each aspect of that information, the product, the year, the pricing, time period, those are all different data dimensions. Okay, so you can look at very multi-dimensional type of data because you're getting data from all different sources and you're putting it into one place in that data warehouse. Okay? So this is, they use this cube model, and to me it always looks like a Rubik's Cube, but it's the idea that you have very multi-dimensional data. You're able to see data and pull out data from different, with all of these different dimensions. And they only show 3 dimensions, but there's a lot of other, you know, dimensions that you can see in some of these data warehouses. Okay, so here you can see actual and projected sales for different regions as well as different products. Okay. Data mining, this is more discovery driven than online analytical processing. You're finding hidden patterns, relationships, and things in large databases that might help to infer what future behavior. Okay, so I'll give you a quick example. And hopefully I didn't tell this story already. There was a grocery company that did some data mining on their sales patterns, and they did an analysis called a market basket analysis. Okay. Did I tell you guys? Okay. So anyway, it was the beer and diapers. You know, Friday night after a certain time, Friday nights, beer and diapers were selling, right? Those are the types of interesting patterns that companies can find using these tools, using data mining. Okay. Some of the different types of information include associations, which are connections. Sequences, these are events that might follow one another in some sort of timeline. Classification, This is where you're looking at, you have different categories and you're able to put information into these different categories. So maybe you're classifying really valuable versus not so valuable customers, and you're able to put them into those pods. Okay, clustering, you do clustering before you have classification. So maybe we don't really understand what the groups are, but we are able to put them together on this, on this axis chart, and we're able to see that there are clusters of information that have a lot of similar characteristics. So we can start to figure out what the groups are from looking at the data itself. Okay? And then of course forecasting, which is where you're looking at past patterns to predict future behavior. Okay? So predictive analysis is also another tool where you're looking at trying to figure out future conditions based on past data. Text mining is where you're taking a lot of unstructured data and you're finding information from that. Stored emails are an example of that, right? You have all these emails, lots of unstructured data, and you're able to pick up patterns and information from, from that text data. Okay, web mining, the internet with all of our interactions, customer interactions, web visitors, there's a lot of data out there that companies collect without you even knowing. You go onto their web page, you're navigating through their web page, they want to know how you're navigating, which toolbars you use, how do you go from one part of the website to another. What happens when people put things into their shopping cart and abandon their shopping cart, right? Companies want to know about why that happens and how they can, prevent those things, how they can make changes to the structure of their web page so that it's easier to navigate, right? So there's some of the information that they might collect from web mining include things like content mining, looking at information from content of web pages, structure mining, looking at the links from to and from a particular web page, and a lot of this stuff right here, this comes in when you're looking at your search engines do a lot of this stuff, right? They actually, when they're looking at links to and from a web page, that's part of the Google algorithm to figure out how high in a natural search results a particular web page shows up, okay? And then usage mining, which is actually where you're looking at interaction data. It was recorded by a web server, how people are navigating through a particular web page. Now, databases, using the internet and using browser software is a very inexpensive way to provide access to databases and data on the internet.
Hello Business 410 online students. This is your instructor Nicole Lytle-Kosola. Unfortunately, the camera I was using to record my lectures this past Tuesday cut out a little bit before I was finished with Chapter 6. So I'm recording this short video to finish up the last few slides and information in Chapter 6. In the video, I was talking about databases on the web and some of the advantages for using the web for database access. Some of these advantages include the ease of use of browser software. A lot of people know how to use browsers and are pretty familiar with it. Using a web interface for accessing a database creates that distance, that distance between the application and the database itself, which means if you have to make changes to the interface, you don't have to make any changes to the database, which is a good thing. And it's inexpensive to add a web interface to a system. So those are some of the advantages for business. This figure 614, shows you one possible architecture for linking databases, internal databases on the web. So you have a client web browser accessing the web server using the internet. A web server connects to an application server, which connects to a database server. You'll notice that it is 3 levels deep of servers. And that database server connects to a database, which is where your internal data is at. Now, for any organization, managing data resources is extremely important. They have to have policies for how they deal with data, how they share data across the organization, as well as with outside stakeholders, how they manage that data. So some of the policies include data administration, data governance, and data administration, database administration. Okay, so general data administration is where you're looking at general policies for and procedures for how you manage your data. Part of the having an information policy for data resources includes having a privacy policy available for customers and other outside stakeholders to understand how you're using their information. Data governance is also important. This is policies and procedures for managing availability, usability, integrity, and security of enterprise data, all of which are very important, particularly as it relates to government regulations. So there's been a lot of government regulations in regards to data and how organizational data is shared. If you're familiar with Sarbanes-Oxley, that's actually a data administration type of rule that governs the type of data that is shared with outside stakeholders, including shareholders and government agencies in regards to your organization. And then, of course, database administration itself, and this has to do with defining, organizing, implementing, and maintaining the database itself, which these policies are performed by the group that is responsible for database design and management. This could be your IT group. It really depends on the organization. Ensuring data quality is very important. It's not enough to get access to data and to have systems that provide business intelligence. If the data that's coming in is not good data, then it doesn't do you any good. You're making decisions based on poor data. So your book quotes that more than 25% of critical data in Fortune 1000 company databases is inaccurate and incomplete. Now, inaccurate and incomplete, those are both issues. Getting data that's not correct is bad, but also getting data that isn't complete, making decisions on using data that doesn't provide you with all pieces of the puzzle is not good. And a lot of these data quality problems, they stem from faulty input. So usually when there's some kind of problem with the data in a database, it's because what's coming in has problems. So before any organization puts a new database in place, they have to identify and correct the faulty data. They have to figure out where it's coming from and try to figure out how they can correct that. And then, of course, establishing better routines for editing the data. So making sure that it doesn't happen again once you figure out where the issue is at. Organizations can do a data quality audit, which is sort of like an audit or a sampling procedure in manufacturing, where you sample, one part out of 1,000 or something like that, and just to double check and make sure that your random sampling technique, that you're getting good quality output. In this case, it's data. Okay. And some of the ways you can do that include survey samples of data files, or surveying end users and actually asking them, is the data coming out of this system helping you? Is it good quality? Is it not? You can also do data cleansing. There's software, data cleansing software that helps to detect and correct data, to figure out, is there data that's incorrect, incomplete? Is it improperly formatted, or is it redundant, which is a problem too. This data cleansing software helps to enforce consistency among different sets of data from different separate information systems. So, as we talked about data warehousing, you're getting data from a lot of different systems, and if you have data that is redundant, you want to make sure that what's coming in from these different systems is correct, and that you are enforcing some kind of consistency. Okay, so that's the end.